7, Unit 2, Solving. Lesson 3, Part 1, Factoring Expressions Using the GCF, Greatest Common Factor. For factoring expressions in the distributive property, first a couple of vocabulary terms. Factor, the verb, means to rewrite a number as a product of prime numbers, also known as prime factorization. This is where you do the factor tree thing, which is shown down here. But 48 could be rewritten as 2 times 2 times 2 times 2 times 3, or 2 to the 4th times 3. 26 could be rewritten as 2 times 13. It's written as numbers multiplied together. Factor also means to rewrite a sum as a product of a common factor and a sum. Use the distributive property to remove common factors from the sum. For example, 4 plus 2x, because both of these numbers are divisible by 2, I could write it as 2 times parentheses 2 plus x. Also, 36 plus 45, 9 goes into 36 and 9 goes into 45. It's the greatest common factor. So I can do 9 times 4 plus 5. Greatest common factor. The greatest number that divides evenly into 2 or more numbers. For example, the GCF of 12 and 16 is 4. Because the biggest number that goes into 12 and into 16 is 4. The greatest common factor of 18, 54, and 72 is 18. That's because 18 is the biggest number that goes into all three of those. 18 is 1 times 18, 54 is 3 times 18, and 72 is 4 times 18. Finding the greatest common factor of a set of numbers can be done in a couple of ways. Below are 2 examples of different methods to determine the GCF of 36 and 60. Method 1. List the factors and find the biggest factor in both sets. So the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. The factors of 60 are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. The largest number in both sets is the number 12. Therefore, the GCF is 12. The other way, method 2, factor, definition number 1, each number as a product of prime numbers. Next, circle every factor that is common, then multiply those common factors. So 36, you can see here's the factor tree. That gives us 2 times 2 times 2 times 3. And 60, here's the factor tree. It gives us 2 times 2 times 3 times 5. Notice that both prime factorizations have 2 2's each and a 3 at a minimum. All the things they have in common can be multiplied together and give 12. So there's 2 methods for finding the GCF. Okay, determine the greatest common factor of the set of numbers, 14 and 49. Well, 14 is 2 times 7, and 49 is 7 times 7. So actually, the prime factorization one is what I would use here, and 7 is in both of them, so the GCF is 7. Okay, example 216, 24 and 15. Well, 24 is 6 times 4, that's 2 and 3 and a couple more 2's, so it's 2 times 2 times 2 times 3. 15 is 3 times 5. The only thing they have in common in their factor lists is 3. So the GCF is equal to 3 here. Okay, 72 and 112. 72 is 8 times 9. 8 is 4 and 2, which the 4 goes into a couple of 2's, so we get a bunch of 2's. 9 is 3 and 3. So 72 is 2 times 2 times 2 times 3 times 3. Let's see what we can get out of 112. 112 is obviously an even number, so 2 goes into it. 2 goes into it, how many times here? 56 times? I know 56 is a multiple of 2 as well. It's 2 times 28. 28 is 2 times 14, and that's 2 times 7. So we got 1, 2, 3, 4 2's and a 7. That's 112. So what they have in common, they both have 1, 2, 3 2's, and that's it. That's all they have in common. So the greatest common factor is 2 times 2 times 2, which is 8. Greatest common factor here is 8. So factoring an expression using the GCF and the same basic concept. In order to factor an expression, the GCF of the terms must be determined. Then the GCF is factored from each term and rewritten as a factor on the outside of the parentheses. Two examples are given. Factor the expression 2x plus 10c minus 4. First, find the GCF of 2x, 10c, and negative 4. Well, the GCF of all three of those is 2. 2 is the biggest number that goes into all three of them. So we factor 2 out of each of the terms. So 2x, with 2 factored out, is 2 times x. 10c is 2 times 5c. And negative 4 is 2 times negative 2. So the 2 comes out, and left inside are x plus 5c plus negative 2. And that gives us our answer, 2 times parentheses 5 plus, or x plus 5c minus 2. Okay, second example. Factor the expression 27f plus 144. Find the GCF of 27f and 144. Well, if you list them, you'll notice that they both have 2 3's in them, and that's the only thing they have. 2 3's make 9, so they do have 9 as their greatest common factor. We're going to factor 9 out of the terms. 27 with 9 factored out of it is 9 times 3, so 9 times 3f. 144 with 9 factored out is 9 times 16. So we take the 9 out and we're left with 3f plus 16. So 9 times 3f plus 16 is the answer. So let's factor 24x minus 18 using the GCF. First, let's factor them. 24x is 2 times 2 times 2 times 3 times x, and 18 is 2 times 3 times 3. They have a 2 and a 3 in common. 2 times 3 is 6. So we are going to factor out a 6. So 24x minus 16. Well, 24 is 6 times 4x, and 18, I actually don't like writing it exactly that way. I'm factoring out a 6. 24 is 6 times negative 3. And there you can see that the 6 comes out and I'm left with 4x and negative 3. And I am done there. So the 24x minus 18 is the same as 6 times parentheses 4x minus 3. You can also use the distributive property to factor out any rational number from the expression. And we're going to see examples of that a little bit later in today's lesson. So doing the examples on page 26 in your notes, example 218, 4x plus 18. All right, biggest number that goes into 4 and into 18 is 2. So I'm going to factor out a 2. If I factor a 2 out of 4x, well, 2 times 2 makes 4, so 2 times 2x is 4x. 18 is 2 times 9. So I factor the 2 out completely, and I'm left with 2x plus 9. Okay, next example, 12j minus 32. The biggest number that goes into 12 and into 32, well, 12 is 4 times 3, and 32 is 8 times 4, so they both have 4. Can't do anything bigger than a 4. So we're going to factor a 4 out of each of these. 4 times 3j will give me 12j. And 4 times negative 8 gives me negative 32. So I can factor the 4 out. 3j comes down in, and negative 8 comes down in the parentheses. And we get 4 times 3j minus 8. 4 times 3j minus 8. 49k minus 21p plus 35. All right, I noticed that 7 goes into all of those, but 49k is 7 times 7 times k. Negative 21p is negative 1 times 3 times 7 times p. And 35 is just 5 times 7. The only thing I see that they have in common among all of them is a 7. So we're going to factor out a 7. 49 is 7 times 7, so 7 times 7k. We're going to factor a 7 out of the other two terms as well. 7 times negative 3p is negative 21. And 7 times 5 is 35. So I'm going to pull the 7 all the way out. I'll just bring down the parenthesis stuff. 7k plus negative 3p. I'm just going to write it as minus 3p. And plus 5. And that is factored completely. Okay, a couple more examples. Factor each expression using the GCF of the terms. 9 and 3, biggest number is 3. 3 times 3c is 9, and 3 times 1 is 3. So we pull it all the way out. We get 3 times 3c plus 1. Okay, next example, 24a minus 12b plus 18c. The biggest number there, I think, is 6. This is 6 times 4, this is 6 times 2, and this is 6 times 3. Yeah, 6 is the greatest common factor. So 6 times 4a plus 6 times negative 2b plus 6 times 3c. Okay, just dividing 6 out of every one of those. Pull the 6 all the way out and bring down the parentheses. So 4a minus 2b plus 3c, and that is done. Next example, 3x squared plus 18x. Well, 3x squared is 3 times x, and 18 is 2 times 3 times another 3 times x. They both have a 3, and they both have an x, so we can pull out 3x from both of these. 3x times x is x squared, and 3x times 6 is 18x. So I pull the 3x all the way out and bring down the parentheses stuff. 3x times x plus 6.